Thanks, Rob. So us four were just upstairs, like spitballing what problems are left to solve. And Ryan had a funny comment. This is year 4 of NEMS. I've been lucky enough to be a part of 3 of them. And I think it's true that in these 4 years, it's a pretty big problem that the largest distributor of all these Bitcoin mining machines that bring us together in this industry has never attended. Is that the case? Has MicroBT or Bitmain ever been here to? Okay, okay. Well, I think that's one of the big problems is so let's just take that. But we're all here with developers, project leads of the 256 Foundation, working to open source and dismantle the proprietary mining empire. And we think there are a lot of problems left to solve. So without further ado, let's welcome to the stage these guys here. And what is the 256 Foundation, just real quick, Eco, as the project lead?
The 256 Foundation is a nonprofit on a mission to dismantle the proprietary mining empire. You can make tax-deductible donations to the foundation, and that money gets used to fund open source developers who are working on open sourcing the entire Bitcoin mining stack. And I think a lot of people get caught up with how small the solutions are right now. Like if you look at a BitAxe, for example, it has a single ASIC chip. And a lot of people look at that and they kind of laugh it off as a toy. It's something cute that you run on your desk. They look at the cost per terahash. They look at the nominal hash rate, and it's laughable in contrast to a multi-billion-dollar industry built on industrial platforms. But I think what people are missing is that the manufacturers of 80% of the Bitcoin mining hardware that runs the network has been extremely antagonistic toward the end users. So we are working with no documentation, no help, no assistance. And the reason that these solutions that you see before you today are so small and minuscule is because they've had to be reverse engineered. So we've had to reverse this entire process down to the single chip and start at the very beginning. So what you're seeing today is just the first step and the very first little inkling of open source Bitcoin mining solutions. We are literally memeing into reality something that has never existed before. And stick with us. It's going to happen. These solutions are going to get more powerful. They're going to get more sophisticated. They're going to get more streamlined. But the 256 Foundation needs support. We need resources. And what we're going to do today is explain to you why open source is so much better in the long run than trying to build your entire business model on these closed and proprietary black boxes like the Bitcoin mining network is running today.
I have a light mode. I have the light mode version of the 256 tagline, and that dismantling the proprietary mining empire. My light mode version is that we are building the open source mining ecosystem.
Yes. So
the optimistic view.
That's something actually that I found myself explaining more than once this weekend, this week, is that that sous vide over there. That's not an end product that you intend to sell, is it, Ryan? I know you put it together. The team was up till 11 p.m. the night before the telehash getting it ready, but this is really all about reference designs. And I think not many people here may be familiar with what a reference design is. I wasn't, at least 6 months ago. And so I view it in my mind kind of as like a recipe, right? Do you want to elaborate on that and the intention of what this physical manifestation in software and hardware is, and where people can take that building block, that ground level, and go from there?
Sure. Well, first of all, it's a demonstration. It's meant to be an inspiration. Here's sort of, not just a circuit board on a table, but here's sort of a live system. Use your imagination and scale this up to being a water heater or a pool heater or whatever. And secondly, it is a reference design. These boards, this software is meant to be an example that you could take. It's common in the electronics industry, if you're trying to sell a chip, that you design a reference board, a reference board that an engineer who's building a product with your chip, they get a first version of something that sort of works, that they can probe around, that they can test with. And they're not going to use your reference board in their product, but they're going to use that as a design examples. They're going to look at the real thing. They're going to look at the circuits, the software, and then port that over to their product. So we're not making a product, we're making a demonstration and a reference.
Well, Ryan just alluded to the fun gadgets, the tinkering, I'm going to mine at home, I'm going to heat a hot tub like you've got outside. I think a lot of us that have been itching to do that have felt the pain more so than the larger scale miners, just because the machines don't work in the house really well anymore. They're too loud, they're too noisy, they're too power consuming. But I think what I want you to expand upon is how this open source platform, the 256 Foundation, these core pillars, these building blocks are useful to the larger scale guys as well. Why do you think?
Well, it allows them to build hardware specific to their need, right? In my specific case with the hashtop, I'm very interested in as much heat as possible. If you talk to like more the grid system, they're more interested specifically on stabilizing their small grids they're building. Big miners are maybe interested specifically on efficiency because that's what makes you all the money. But today, the hardware that we all use is kind of good for all of it and nothing. But nobody can take their miner or their hardware or their software and specialize it specifically for that, right? I've talked to people that building data centers or like mining data centers, and the variable of the miner, the width of the miner is a fixed thing. So this is fixed and you cannot change it. And so you're building everything around that fixed width. And now what happens 6 months later, the company makes a bigger miner and you can basically throw your whole data center in the bin and rethink. But imagine you can build your own miner, or you can have a company that builds it for you that is and you can actually specify the width. Imagine what is the crazy world we're living in that you can actually go to somebody and saying, hey, I want a miner that is this wide, this deep, this tall, uses that much power, has this cable connector, because whatever cable connector that Bitmain chose or MicroBT is not available. Like imagine that world that you can actually work together with your hardware producer to build the miner that you specifically need for your specific use case. And in the end, what you're going to get out of it is better efficiency, less hardware repair, just happier shareholders, happier employees, happier everything. And today, we are all, and I'm the worst of this, right? I'm trying to use a miner that it was not made ever. The person that built that M64 that is out there never thought about heating a hot tub with it. And I'm just trying to cherry rig and add things that it kind of can make it work. And I believe all of this also happens on a big scale. It happens on a small scale every single day. And the reason for that is that the hardware is fixed. The person that builds the hardware does not know about you and actually mostly doesn't even care about you.
And I think that goes to highlight other problems that stem from that root. And it's like we're seeing the S23s get pulled from the shelves. We've seen recent firmware updates with the AMP miners that prohibit connecting to certain pools on day one. The company has provably been shady, to say the least, in the past with AMP bleed and ASIC boost. So, like, to build a company that depends on these sort of black box solutions that you have no control over, you have no say on, and you're just kind of beholden to whatever they throw at you, is just ludicrous, in my opinion.
Can I ask you a question, Tyler?
Please.
So on this, to some extent, the sous vide, even the hot tub is a. Can you, since you wrote the book on this, can you give us a couple numbers that show like the potential? Why is heat and Bitcoin co-production such a big deal?
That was a very generous setup. Yeah, I think that home mining, specifically more utilitarian mining, is a big driver for a lot of these initiatives, because the machines as they exist today were designed for these data center applications. They've converged on this over time. I think we can even see that with the the rug pull of the S23 air cooled, right? Like everything's going to these blade style 2U form factor, 380 volt power, more data center, more analogous to AI, that kind of industry. And for the folks that just want to mine at home or in their businesses and get some utility out of it, our friends from Gridless are in the room as well. But specifically, I'm focused on the heating thing. It is wild. Like half the world's energy is used for heat. Half of that is comfort heat, warming water and air. And I'm probably there's like a zettahash of sous vide energy out there that we could get online. So it's a huge market, huge potential. But as you guys were answering the question, you just got me thinking, which is in this closed source proprietary mindset. This is not to say that Bitmain and MicroBT and Canaan and all the likes aren't trying to solve their own problems. They perhaps are trying to have more efficiency. Sometimes they create more problems. The aftermarket firmware companies come in, they'll try and solve problems, right, to give you some more performance, things like that. Dynamic performance scaling from Brains or ATM from Luxor. These are cool features, but because it's built and predicated on closed source underpinnings, it ends up creating problems for other people. And that's something cool that I think is unique about open source, where it's like you solving your own problem does not create another problem for someone else, which is very interesting. So with that, for anyone that's unfamiliar in the room, Eco, I would like you to give a quick rundown of the 4 core pillar projects of the 256 Foundation, why you chose those specific projects, and what problems they aim to solve.
Yeah, so our goal was to open source the entire Bitcoin mining stack. So there's now a standardized design for an open source hashboard, an open source control board, an open source mining pool, and open source firmware. And we felt like those were the 4 projects that would enable the entire Bitcoin mining stack to be wide open for everybody. So the hashboard is called Ember 1. The first one we did used the Bitmain chips. The second one we're doing is going to use the Intel chips, which Proto graciously donated to the 256 Foundation last year. The firmware that we're building can support a range of ASIC chips. It's meant to have different drivers loaded so that it can support any kind of hash board with any sort of chip. The Libra board that Schnitzel was the lead engineer on is meant to give the end user full range. If they want to run a node locally, they can do that with the Libra board. They can control up to 4 hash boards with it out of the box as it sits. And there's an HDMI connector there. We put as many bells and whistles on the Libra board as we could to give end users maximum control over auxiliary systems like temperature sensors and whatever they wanted to implement mining and heat reuse applications for. And then Hydro Pool, we showcased with our fundraiser on Wednesday, where the telehash is still running on the initial release of Hydro Pool. So that's a easy to deploy Bitcoin mining pool that anybody can grab and spin up themselves. The 256 Foundation does not intend on being a pool operator. We want other people to be pool operators. We want other people to figure out clever payment schemes. We built PPLNS into it by default, but we want that to be a springboard for other people to find other clever solutions, ways to handle payments that go to the miners without the risk of a custodian in between. And we just think that putting an extensible and modern code base out there for people to have access to is the best way to springboard all sorts of innovations that we haven't even thought of yet.
So the whole thing shouldn't be built on CG Miner?
I think we're past that.
Well, while we got the lead developers here, Ryan from Mujina Firmware and Schnitzel from LibraBoard, why don't you talk about, let's start with Ryan, some of the problems you aim to solve with this first iteration of Mujina, what is on the docket to polish up and tidy up, what you're looking for from the community, and then later on in the discussion, maybe we can just spitball some fun ideas.
Sure. Well, we spent all this time talking about demos and reference design. Actually, Mujina is the one piece, and Hydro Pool are pieces that aren't exactly just reference design. The ultimate goal for Mujina is that it becomes the Linux kernel project of Bitcoin mining. And so we want to be able to support every hash board out there and run on any control board out there. So we've taken the first initial steps. 0 to 1 takes a lot of time. So now it's time for 1 to 10. But we support basically 3 hash boards, right? 2 hash boards. We've got, well, it can CPU mine. That's not much of an achievement. We can use a bit axis. You can plug in a bit ax as a reference. It's just a development hash board. We support our Ember 1 hash boards now. And we're actually behind the scenes working on an industrial miner also, being able to drive hash boards from an industrial miner. So hopefully demo that soon. So hash board support, Libra board is brand new. So we're looking to implement all the features that are available there and grow Mujina's community. We want contributions from people who want it to run on their hash boards and on their control boards. So those are the kind of the near-term goals: more hardware support, bigger community.
You glossed over the CPU mining part, but I want to highlight why that was so important. Can you talk about the testing we did real quick on Hydro Pool before we launched the telehash?
Yeah, so one of the really interesting things about testing or load testing a pool is that if you go outside of the pool world, let's say like you want to test a web server that like how many people can visit the website, it's super easy to fake traffic because you just take an existing traffic and you send it a second time. The problem is with mining, right? It's proof of work. So in order to test a pool, you actually need to mine to it. Now, how do you test a pool with, let's say, 4,000 to 5,000 miners if you don't have the 5,000 miners? And so we figured out that if we can run Mujina, which has a CPU capability, we could easily deploy 4,000 to 5,000 Mujinas all over the world in clouds and point it to the pool. And for anybody who knows the difficulty, you can actually make the difficulty super simple. But that allowed us to actually properly test, can we accept 4,000 miners? That was like the thing. On the telehash, we were up to 1,000. But it's really funny, right? You're trying to load test a system that is meant to not be load tested. So yeah, that was super helpful that we have a CPU miner. It's funny, like how much hash rate does one CPU generate?
One CPU all-out might be on the order of 5 mega hash per second.
Yeah, so you realize how crazy these ASICs are, that like your regular computer does 5 mega hash. So my 4,000 miners that I deployed, that cost me maybe like $50 an hour, running on AWS, they didn't even get to 1 terahash, which is what one BitX just does over that. So it's a fun fact of like, if you think about how optimized these ASICs actually are, it's crazy fast.
And just to be clear, what we were testing, it's not the amount of hash rate that puts the burden on the pool server. It's the number of connections. And so that's really what we were trying to simulate with that test. But because we had control over the firmware and the pool server software, we were able to configure the pool to accept difficulties lower than 1. And
that's because it's open source, right? We could just
Right.
go in, change the code, deploy a version that we obviously didn't deploy the version during the telehash, because then anybody could have sent us shares that wouldn't have worked. But yeah, because it's open source, we can just go in, change a short version, deploy, test it, verify it works, and then deploy the real one. If we have a proprietary pool software that we would want to run the telehash on, we couldn't have done it. We just could have hoped that it works. And that's the power of open source, that you can go in and actually understand how it works and change it to your needs.
And I think that's the beauty of doing these projects in tandem too. You guys talked about this during the telehash live stream the other day. So much learning happened. I mean, before we dive into LibraBoard, Michael, tell me about this HashScope project and why you had to build this for development as a problem you had to solve, a technical problem you had to solve to figure out the whole other part of the mining tech stack, the open source communication to the pool, back to the hashboard and the firmware.
Yeah.
What's this thing you created in the middle?
During this whole thing, like we thought about how can we test 4,000 miners? How could we do that? And one of the things that we looked at is like there's no Stratum v1 debugger. So the pool and the miner, they talk a protocol with each other, but there was no visualization. So through the powers of vibe coding, I literally went to Cursor and said, hey, I need like a way to analyze and visually look at the traffic. And it basically implemented me a man-in-the-middle debugger that I can point the BitX or any miner. I pointed to this man in the middle, and then he points it to the pool, and it visually showed me all the traffic that goes back and forth. And it actually, during the telehash, we had some weird issues with LuxOS that it didn't want to talk to the Hydro Pool. So I told one of the miners that was here, pointed to the debugger thingy, and I was able to show the traffic back and forth. We were able, within like half an hour, figure out what was that. There's a slight difference, because the problem is Stratum V1, the protocol that the miners in the pool talk to each other, there's no specification. There's literally no spec out there. The only way to implement it is to look at existing code and try to re-implement it. And so for us, the only way to really test it is just to ask as many people as possible to point their hash rate or to point the different miners. And now it's becoming a tool that we actually can use for load testing. We found security bugs with it. So yeah, just visually trying to see how does the pool react, right? Because usually the miner sends one hash only to the pool, like, or one share, sorry, and it finds it. But you can test like, well, what happens if the same hash gets sent a second time? So for all the pool operators out there, we'll maybe test your pool over the next couple of weeks and see if it's actually secure.
But you also learned this week that, not just as a debugging tool, but this proxy feature, a man in the middle, is actually something useful that many other miners might be interested in.
Correct. So I've talked to a couple of miners, and they currently have no way to actually verify if all the shares that they miner sent to the pool actually arrive there. So one of the things that we're looking at is to extend that to have like a little proxy that you send all the shares. So like say you have one site and you point all your miners actually to that single proxy, and it sends all the shares still to the pool, but it also counts all the shares. So it knows all the individual shares that is sent to the pool. And then you go to the pool and say, hey, pool, prove me that you have all these shares received. And you do this like with hashing. So you basically create a hash locally of all your shares, and you ask the pool to create all the shares. And if that hash matches, you know the pool received all the shares. If not, you know something went wrong. And that could either be the pool maybe just threw some of your shares away because you have no way to prove it, or even worse, there's somebody that sits on your internet connection, because everybody that knows Stratum V1 is unencrypted, publicly accessible. So if I'm your internet provider, I can steal your share. I can steal your hash. Now, if I completely steal it, you will figure it out, because on the pool they will show 0, but I can steal 1%. Like whoever has measured all the hash rate of all the shares of all the miners and went to the pool and counts the correct way. I've not met every it's hard if you have 50,000 miners. But these are the things that we're finding while building all of these stuff and talking now. That's why NEMS is great. Like I can literally talk to different mining operators and saying, have you ever done this? They're like, oh no, I've not. So yeah, that's one of the projects that comes out of all of this, that we want to do like a share counting tool that you can prove, and who knows which pool is actually doing the right thing or not. I think it's going to.
So you're telling me that Bitcoin mining has a lot of trusting and not a lot of verifying.
Correct.
Okay. Igor, why don't you expand upon why this verification, not trust, is important, not just for share accounting and, getting your money's worth, but also sovereignty, regulatory landscape, the whole like.
Yeah, I mean, real quick, I want to point out too, like speaking of having a % or 2 shaved off, like if you're running Mujina, there's no dev fee. So all the aftermarket firmware providers shave off a dev fee. So if you are running stock firmware, you're already at a disadvantage. Even if you upgrade to another aftermarket solution, it's still closed source and you're paying a dev fee. But like with Mujina, there is no dev fee. I think there's the optionality if you wanted to make a donation back to the 256 Foundation, but there is no dev fee. But
yeah, I would phrase that like, if you choose to run Mujina as your firmware, you're running your own firmware.
Right.
So you don't need to pay a dev fee to yourself.
Exactly.
You could fine yourself, or you could donate hash rate to the 256 Foundation.
Yeah, I want to jump in here. First of all, huge round of applause for these guys. These guys are legends. We actually have a good bit left on the panel, but I want to highlight a couple things. Who knows what this telehash is all about? Raise your hand in the room. Cool. one of the coolest things, how many workers did we get pointing hash?
Around 1,000.
Around 1,000. And so we had 1,000 unique miners pointing hash rate to Hydro Pool. All right. May 19th is our next telehash. We got to 10x that. So 10,000 miners is our goal consistently. Everyone here can contribute to that. All the hash donate. Well, we're going to verify now. We're not going to fucking trust anymore. We're going to verify all that hash. So if you're running even a BitAxe, any of your miners, shout out to Guardrail, Megawatt, Gridless, Electron. The list goes on. I'm going to miss a million folks that were on
Nice hash.
Nice. Well, yeah, I'm going to get the nice hash in a second, but individual miners that were able to point their hash rate to 256 Foundation Hydro Pool. Then that's one group. Then there's another group that's lazy AF. I'll put myself in that group. You can actually go, whether it's Nice Hash, Brains, or Wrigley, and go buy hash rate and point it to the 256 Foundation. So that's going to be on May 19th in Austin, Texas. So I just wanted to highlight that. But how else can this group support you guys and the projects that you guys are leading?
I mean, from my side, it's just talk to us what your needs are, right? That's like I'm building the Libre board, which is the control board. I've talked to a lot of more like the heat punks people that are interested in temperature sensors and relays and that stuff. But like we want to build this, like we're talking about, like we're building the base that you can take it and build your own hardware on top of it. But the more that we understand what you will use it later, the better we can build the base. And so, yeah, tell us what, let's say, if you have 10,000 miners, what would be the best control board, the hardware? Like, what is the connection? Is it Ethernet? Is it fiber optics? Is it Wi-Fi? Is it C-Wave? Whatever, like, what is the protocol you're talking about? What do you plug in? Do you want the small display? Do you want the big display, right? What is the IP address of the miner? I have no idea because there's no display. Like, just talk to us and tell us your problems or the things that you would love to fix, and that helps us to build the system. We might not specifically implement your problem, right? Again, we're not solving the real problems, or we're not building hardware you can buy off the shelf, but we're building the base that will allow you or partners to then build it yourself to solve your problem.
Eco, on the social side, like we have Telegram channels, we have OSMU, we have a number of ways for these miners to communicate and work directly with us. Yeah. What are some of the best ways for them to stay involved?
Yeah, I mean, if you're looking for community support, there's the 256 Foundation Telegram channel. There's our website, 256foundation.org. You can go there and find links to all of our resources, including the GitHub organization and all of the repositories that are on there. Financial support is great, and it's probably the easiest. Hash rate is also really fun when we're doing these fundraising events. For anyone who doesn't know, we did actually solo mine a block last year, and we funded these that's what bootstrapped the foundation. The other ways that we can use support, though, is developer resources, engineering resources. Since last year and funding those projects, we've designed the hash board, the control board, the firmware, and the pool. And I have a pick and place machine behind the stage here where I actually built the physical hardware. And if any of you saw the demo next door that Ryan set up, we had the hardware running with the software that we built. So that all came together in about the last 8 months. So the money and the resources that have gone into this foundation are actually manifesting themselves in real solutions, and they have been on display throughout our fundraising event this week. And we're just thrilled to get any support we can, whether that's people donating chips, people donating tools and supplies, people donating engineering or developer resources, comments, issues on GitHub. More eyes we can get on these projects, the better. So there's a number of ways that this can be supported.
And I'll say this, it'll go public on February 1st, but there was a coup and I got kicked off the board of the 256 Foundation. And No, I'm just joking. But Tyler Stevens and Scott, who's the instigator of the BitX project, are going to be joining the board of the 256 Foundation for this next evolution of this growth. So if you're looking for, I mean, it's going to be unbelievable when they're all sitting here next year. What are we going to be like, surveying like a freaking whole cow or something? I don't know. But I cannot wait for that. Any closing thoughts from you?
I'm strongly of the opinion that this isn't a real industry until we have a commoditized layer, an open source layer of building blocks to support each other on, a community to build upon. And when I asked Scott yesterday, we were literally asked this question you just were prompting us with, how do you get involved? Do you know what Scott said to me? He said, make a fucking pull request. So we'll leave it at that.
Let's give these gentlemen a huge round of applause.